Before we start, if you're enjoying these conversations, please make sure that you like or subscribe to Cleaning Up. It really helps other people to find us. Cleaning Up is brought to you by Capricorn Investment Group, the Liebreich Foundation, and the Gilardini Foundation. Hello, I'm Michael Liebreich, and this is Cleaning Up. And quite extraordinarily, this is the 100th episode. My guest today is Dr. Jennifer Holmgren, CEO of LanzaTech. LanzaTech describes its process as like fitting a brewery to the back of a producer of industrial emissions, like a steel mill or a municipal waste dump. It takes the pollutants and, using a proprietary bacteria, turns them into useful fuels and chemicals. Fascinating. Let's welcome Dr. Jennifer Holmgren to Cleaning Up. Jennifer, thank you so much for joining us here on Cleaning Up.
Oh, it's such a pleasure, Michael. It's wonderful to see you again as well.
Now, where are you calling in from? Where are you today? That looks like some kind of a home office. Is that right?
No, actually, I'm in our office in Chicago. Our labs are in Skokie, Illinois, and this just happens to be one of our conference rooms.
Oh, very nice. I couldn't see there exactly what was in the background, but you have very nice, cozy conference rooms. I never know when I talk to you whether I expect to see you kind of in a lab coat and still doing practical work or stalking the corridors and doing the financings and so on.
Yeah, I haven't done practical or useful work, as I like to say, for a really long time.
How fun. I don't know if that's something you'd like to get back to at some point.
I think it's too late for me to go back to the lab. This is my last gig, I think.
Well, my worry is that although I might think that I've done my last, financial model or my last spreadsheet, my last experience curve calculation, I'm a bit worried that I might have to go back to that, get back to the if the day job doesn't work out. Where I'd like to start. Okay, so you are the CEO of LanzaTech, and you've got this LanzaJet spin out, and you've got all sorts of things going on. But I'd love to hear, in your words, describe what it is you do, what the company and the companies do, in your words. And remember, the audience is fairly general. They're smart, but they're generalists.
Yes, so the simplest way to think about it is that LanzaTech is trying to make all the products you use in your daily lives, whether it be sustainable aviation fuel or polyester or foam for shoes, all of this from recycled carbon, from carbon that's already above ground, so we can keep as much virgin fossil carbon in the ground. And so how do we do that? The way we do it is we have a bacteria that ferments gases. So you're used to the fermentation of sugar, right? That's how you make beer. What we do is we make beer, but we do it by fermenting a gas. Hydrogen, carbon monoxide, carbon dioxide, right? Greenhouse gases, things that would be polluting. Our bacteria eats that and makes ethanol. And then we take ethanol and we convert it to everything else, because ethanol can be converted to sustainable aviation fuel. It can be converted to polyester. It can be converted to surfactants for detergents, et cetera, et cetera, et cetera.
Okay, that's fabulous. And because it clarifies then that it all goes through ethanol. So it's all about going from a gas to ethanol. Then how flexible is the gas input?
Oh, it's completely flexible. So I can use an industrial gas that's rich in carbon monoxide. I can use an industrial gas that's rich in carbon dioxide. For carbon dioxide, I have to bring in hydrogen. We can gasify, turn solids into gas, like municipal solid waste, at various ratios, different carbon-hydrogen ratios, no problem. All of that can be converted by our organism to ethanol.
So you start with a gas, as long as the gas has got some carbon in it, right?
That's right.
And then you tweak the ratios by adding some hydrogen if you need. And then that gets the right ratio, and you turn that, and then the bacteria. And is it always the same bacteria, or do you have a whole stable of little bacteria all waiting to be sort of summoned to work on a particular type of application?
Yeah, so we summon them from freeze dry, just so you know, we transport them around the world as freeze dry. So as you say, we summon them to service but it's the same bacteria for all of these gases. Now, one thing I would say is you don't always have to have hydrogen. So if you have carbon monoxide, the organism knows how to make hydrogen from water and carbon monoxide. So it will adjust the ratio itself. Now, if you give it hydrogen, it's easier and it works better, but nonetheless, you don't have to give it hydrogen. In the case of CO2, you have to have hydrogen. And the reason for that is carbon dioxide, greenhouse gas, only has carbon, no energy. So the organism picks up its energy from the hydrogen. In the case of carbon monoxide, there's carbon and energy, just like sugar. And so it just makes its own hydrogen and away it goes.
Okay. How efficient or otherwise is the process? What kind of temperatures does it work at? Give us an idea of what would one of these plants, if you walk into a plant, what would it look like and so on?
Yeah, so the temperature is not much higher than room temperature. These are bacteria like us, they're alive, right? So you can't put too much pressure or too much heat. So we do have it under some pressure because we want the gas to dissolve in the water where the bacteria is. So the bacteria can go ahead and eat it, right? So you have to put some pressure. But it's at 38°C basically, so not high temperature. So this is a much more benign process than in a refining complex. You use very high pressures, very high temperatures. With this biological organism, you're essentially running close to ambient.
So is it a big vat, or have you got the water sort of cascading, or how to see? I'm getting a picture of this.
Yeah, that's a brilliant question, actually. So most fermentation that you're used to is in a big vat, right? It's a batch process, we call it. This is a continuous process. This looks very much like a refinery process. Gas bubbles in, ethanol comes out. And the organism is alive and dividing, so you don't need to keep adding organisms. So the bacteria is in the reactor, and it just continues to divide. What we do, you don't want to plug the reactor. If you can imagine this bacteria dividing, you're going to plug the reactor. So what we do is we take some bacteria out. The bacteria gets dried and sold as animal food. It's 90% protein. So that's our only co-product. So we make ethanol very, very selectively, and we have this bacteria that we need to also remove from the reactor and sell.
Now, the gas that you use, I'm assuming that you can then get that from any biomaterial as well. So you could use a bio waste probe, agricultural waste, forest waste, but then you would have to break that down into gas and then cool it before it came into contact with the bacteria, correct?
That's right. So solids, a solid like municipal solid waste, a solid like agriculture residues, you would gasify that, which is like combustion, but partial combustion, right? And then you cool the gas and you pass it through our bacteria, and you get the same chemistry, the same bacteria, et cetera, et cetera.
Okay, and then but you don't produce any char or anything, because everything gets gasified. I mean, presumably there might be some ash or something like that in the gasification process.
Absolutely. So when you gasify, depending upon which gasifier you use, we don't have our own gasifier. We work with partners that have gasifiers. Some gasifiers produce quite a bit of char that comes out the bottom as a solid. So actually, what we're finding, though, that char looks a lot like terra peta. In other words, it's a very porous carbon. And so you can put that back in the soil, and it retains water and it retains fertilizer. So actually, it's a soil enhancer. And so that's what we're doing right now, is we're validating in India how much work, and in the US, how much of that carbon can be put back into the soil to actually improve soil conditions.
So you've got your end products then are ethanol, animal feed, and then this char, a soil improver.
In the case of gasification, that's right.
In some cases, exactly, depending on the feedstock. Now, let's keep walking down. You got your ethanol. Is it pure ethanol, or is it aqueous? Is it mixed with water?
So the ethanol out the back end of our reactor, of course, is mixed with water. And so what we do is a distillation, which is how you normally separate ethanol, and then we separate the ethanol. Right now, what we do is we turn it into fuel-grade ethanol, which is kind of messy. It's good enough to put in as a blending component with gasoline, but we can refine it further. We can clean it up further. Cody's using our ethanol in their perfumes. The Climate Care Nivea for Men has our ethanol in it. And obviously that ethanol has to be really, really pure, right, to be able to touch your face. And in addition, we have ethanol being used by a company called Mibel in Switzerland for cleaning products. And so you can use the ethanol for a lot of things beyond blending with gasoline, but you have to clean it up.
So one of the last episodes of season 6, we had somebody that you probably know, Julio Friedman from, was it Carbon, what's his fund? But anyway, he was talking, Carbon Direct, I think it was. And he was talking about ethanol and it's all going to be this and that. But it turned out that, of course, what was happening, the company that he'd invested in was producing ethanol at such a high price point that you had to put it into perfume and pharmaceutical products, because as a fuel, it was out by, I don't know, half an order of magnitude or an order of magnitude. Where are you on the cost of your ethanol?
No, so actually right now our first commercial plants are in China and they just sell it for the price of fuel grade ethanol. If we have to do something else with it, like clean it up, then that adds cost, but really it's competitive with fuel grade ethanol. It'll be the same thing in the US and Europe. It will be competitive. So that's not an issue for us. The way we make ethanol is extremely carbon energy efficient, which means it's not overly expensive.
And is that first plant, the one in China, is that BIO Steel?
No, actually, so BIO Steel built our first demo, but they didn't end up building a commercial. So the first commercial was built by Xiaogang Capital Steel in Beijing area. And they built that plant. And actually, it's really funny. So this plant is about 3 hours outside of Hebei, outside of Beijing in Hebei province. And I don't know if you noticed, but there were some ski ramps during the Olympics, and in the background, there were some furnaces. That was the old Xiaogang steel mill that was near Beijing, and that got shut down and they moved it. So those were coke oven furnaces and blast furnaces in the background of the Olympics that you were seeing.
So the reason I asked about BIO Steel is that you and I go back quite a ways now. We first interacted when you, LanzaTech, became a Bloomberg New Energy Finance pioneer in 2012.
Yeah.
And in 2012, the coverage was all about, here's this company, I think out of New Zealand originally, that was doing this thing with BIO Steel that had raised this colossal amount of money, $55 million, I believe it was, at the time. And it was all tremendously exciting. And so I'm kind of trying to link back up with the stories and the coverage, to what extent is what you're doing today, what you plan to do with all that money back in 2012?
Yeah, no, that's great. So actually what we intended to do with that money is build a demonstration facility, show that the technology scaled, and then use that to start building our first commercial. And at the time, we built 2 demos, one with BIO Steel, that was the first, and the second one was with Xiaogang. Xiaogang was able to go to building their first commercial. In fact, they built 3. They have 3 plants running, one at a steel mill, the first one, and 2 at ferroalloy plants. So they've continued on the rollout strategy using our technology in China with waste steel and ferroalloy gases.
Tell me, why is it such a great technology to stick on the back of an alloy or a steel plant? Why does that make so much sense as a starting point?
It's just because both of those have a lot of carbon monoxide, and that carbon monoxide normally goes out the flue, is burned to become CO2. You can't emit CO. Carbon monoxide is toxic. So what they do is they flare it out as CO2 in particular emissions. We prevent that. We don't let it go out the flue. We just capture that carbon monoxide. Carbon monoxide is like sugar for our organism. has carbon and energy. It says yum, and away it goes. And so that's why we started there. And we're really focused on climate mitigation strategies, right? At the end of the day, we don't want carbon being ever combusted and going out of flue. Even if you capture the energy from that, you more than anybody else knows that the levelized cost of electricity from renewables is equivalent to that of fossils. And so what that really says is, why are we wasting carbon, good carbon that can go into chemicals and fuels on power production, right? And so really, in a steel mill where they have to use carbon as part of their chemical process, they always have a ton of carbon monoxide that literally comes off the steel. You just got to grab that stuff and not let it go to waste and turn it into products.
And what are the other processes? Okay, the steel and those alloys plants. What other feedstocks have you started to exploit?
Yeah, so we're building a plant with Indian Oil that uses a refinery off gas that has CO2, hydrogen, and CO, and that gets converted to ethanol as well. They should be starting up that plant before the end of this year. We've also looked at gasified municipal solid waste. We've done a ton of work on that in Japan. And we are also doing agriculture residues in India. So, and forestry residues in Canada. So the solution works. And what I like about it is allows you to access local feedstocks. At the end of the day, this is about a distributed production approach rather than a centralized refining approach, using all the gases that are available or all the waste solids that are available to make ethanol. And I would say, go ahead.
No, I was going to ask, when you say we're doing this in India and we're doing this in Canada and so on, how many plants at a commercial scale have you got operating? What is a commercial scale?
Yeah, so 15 to 30 million gallons per year production capacity is our first commercial scales. And we only have 3 commercially operating, and those are in China. The 4th plant will start up in India. The 5th commercial will start up in Europe. We're working with ArcelorMittal in Ghent, and that will be the 4th plant. And so really we'll have 5 across the world. The municipal solid waste is a large demonstration plant, and the forestry residue in Canada is a large pilot. We are designing a commercial plant in India, actually 2, that are based on gasified residues, agriculture residues.
Okay, and presumably when you look around, you think, well, there could be hundreds or thousands of these, because those sorts of feedstocks are, now steel is an interesting one, because if it goes to a hydrogen reduction process, presumably that doesn't then produce a useful stream of gas for you. But all the other things, there's plenty of other processes that you could use, or feedstocks.
Yeah, and actually, to be honest, the way we think about our technology is, as long as there's CO2, which there will be at a steel mill, even if it just uses hydrogen, there will always be CO2, right? We can use hydrogen then. So if a steel revamps and all it's doing is using hydrogen, and we have a source of CO2, you can still use the same plant to convert CO2 and hydrogen. So it's really quite flexible. So we're actually counting on a future where steel mills and everything else transitions to hydrogen. Because hydrogen allows us to convert CO2. If we can get hydrogen at the right price point, under $3 a kg delivered, we can be competitive making ethanol from CO2. So we also have partnerships with direct air capture companies, carbon engineering, right? Where we are able to use their captured CO2 with hydrogen. But you need hydrogen.
Right, I was going to get on to the capturing carbon, because so far, all the things you've talked about, they are burning the CO2. Instead of going into the atmosphere, you capture it, you put it in ethanol, but that ethanol might become a fuel, and ultimately, even if it's a perfume, it's going to end up back where it was in the atmosphere.
So direct air capture, are you doing that anywhere? Are any of your processes currently using captured carbon?
Not yet, not yet. We've done techno-economic evaluations and looked at locations with carbon engineering, but we don't have anything currently operating. We did a feasibility study in the UK to take directly air captured CO2 from carbon engineering and hydrogen and convert that to ethanol, and then that ethanol to sustainable aviation fuel. So it would be a nice way to capture CO2. Right now, we're not doing any of that commercially.
Right. Jennifer, just share with the audience, when you talk about carbon engineering, that is an organization. Could you just say a couple of words about them, just so the audience knows, because it's not a process, it's actually a company.
That's a great question. So carbon engineering has developed a technology for direct air capture. What they do is they take CO2 literally out of the air and concentrate it so that it can be used as a feedstock. For us, it's a resource.
Right. My concern with that's a great description. My concern with them is that they use a lot of energy, they want to burn a lot of natural gas to do that. So it kind of feels a little bit like a self-licking ice cream, but I've not done all the mass balancers or any detailed work, but they have an approach to direct air capture fundamentally.
That's right. And I think at the end, we need these technologies, carbon engineering, Climeworks. There's many others that are doing direct air capture. I think the natural gas that they use could be replaced with hydrogen in the case of carbon engineering. So I think, to be honest, actually, I'm glad you asked this question, because this is one of my favorite topics, okay? We've got to get a lot of technologies to scale to be successful, right? And each technology, as it gets to scale, just like solar, gets cheaper and more efficient, and people get smarter, right? Today, carbon engineering uses natural gas, but tomorrow they'll use hydrogen. And so the life cycle footprint will get lower and better. And my view is our climate problem is urgent enough that I'm very happy to have 5 or 6 or 7 or 8, carbon engineering and other companies competing for the direct air capture market. Plenty of room for everybody. And I need everybody to scale and to go down the cost curve. And there'll be learnings from that create the next generation technologies. Actually, let me ask you a question, because you brought up a very important point. One of the things that we're all relying on when we talk hydrogen or direct air capture is there being abundant, clean power. And so tell me what your view is on that. Are we going to get there from here?
Well, so this is we see what you're doing there. You're turning the tables on me. The last person to do that brilliantly, by the way, on cleaning up was Tony Blair, because I was sort of starting to push him on all sorts of questions to do with clean energy in Africa, and he sort of very nicely did exactly what you're doing. So green hydrogen is going to become cheaper than blue hydrogen, which is natural gas with capture, and it's going to become ultimately cheaper than gray hydrogen, which is hydrogen made from natural gas with no carbon capture, which is actually 2% of current global emissions is either black hydrogen from coal or gray from natural gas. And eventually green will become cheaper. The problem is that word eventually is doing a lot of lifting, because the thing about an experience curve is that you actually need the experience, you need the scale, you need the supply chain, you need, so as an example, you'll get cheap green hydrogen when we've done lots of it, and we'll get it in places where there is abundant wind and solar that can be linked together, so you get very high capacity factors on the electrolyzers and so on. And so I'm very worried, I'll be honest, that we're at a point in history where people say, well, we did it with wind, we did it with solar, we did it with batteries, so we can do it, or almost, so we have done it, therefore, by extension already with everything we can imagine. And so I worry about that, because right now I can see green hydrogen at, let's say, $2.50 a kilo in certain parts of the world. And by the way, transporting hydrogen is really hard. If anybody thinks that we're going to be putting hydrogen, liquid hydrogen onto ships like we do with LNG, that is delusional. it's going to be homeopathic volumes, I've called it. It's going to be tiny because just the physics, it's not the experience curve, it's not learning, it's not finance, it's not policy, it's physics.
Yeah.
So we will have abundant clean hydrogen at certainly, $2.50. Some of it may be blue in about 10, certainly by 15 years. And then the question is, can we beat that? And the final problem on green hydrogen, then I should get back to grilling you, not the other way around. The final problem is that supply chain to produce all of the renewable electricity for green hydrogen is the same supply chain that we need to produce green electricity for all the things we currently use electricity for, the other 85% of current power demand that is not yet, wind and solar, et cetera. We need the green electricity for heating and for transportation and for all the things down at the bottom of my famous hydrogen ladder that won't work with hydrogen, but that will work on electricity. So I worry that the short answer to my question is don't worry, Jennifer, there'll be lots of very cheap hydrogen, but not till about 2040 or maybe even 2050. That's my worry.
And that is my worry. Actually, and this is something that, to me, there's two elements of what you said that I want to pick on, right? So one of them is this experience curve. And while we use solar as an example, we can't afford 30 to 40 years to get down a curve anymore. That just doesn't work. And it's not going to help us enough to be successful. But I think finance, which is one of your favorite topics, is a path to changing that. Our company has been around for 17 years, right? And, building a pilot and then building a demo and then building commercial. And with the technology, as I told you earlier, we built multiple demos. Every time I have to go out and get cash. Every time I have to figure out how to build the next scale. I cannot make the science go faster. Okay, every time you skip steps in science, it takes you 10 times longer to get it done. So you don't do that. But finance, I see governments, thankfully, now supporting demonstrations and first commercials. Until you've gotten past the first couple of commercials, it's not de-risked and you're not going to be able to get cash easily. So I really think finance and more clever methods to finance scaling and crossing the valley of death for new process technologies will allow us, right, to get down the curve faster.
I'm smiling. Those who are listening on podcast can't see this, but those who are listening on YouTube will be able to see I'm smiling because I think I wrote my first report on the Valley of Death and how to get across it in about 2007 or 8.
Yeah.
And I think we're in a much better place now. I would agree with you. We are in a better place now. And there's governments that have understood much more. There's a whole ecosystem because at the end of the day, you can just make ethanol and there's other people who can now use it. Bioethanol, it can be valued, it can be used. You go back to those years, 2012 when I met you first, or 2008 when I was first worrying about the Valley of Death. Nobody really knew how you put a value on that or what you do with it. So, and then you've got things like breakthrough energy, Bill Gates initiative, who are prepared to put larger chunks of money into more speculative things. We are better, but there's only so much. I mean, it's kind of, I think it's, it may be Warren Buffett who says, you can't get, what is it? He says something like, you can't put 3 mothers together and have a child in 3 months.
Yeah, exactly.
Just like you say, you can't speed up the science, but equally, if you're an investor, you can't speed up the fact that you want to, see it scale and get the metrics and so on.
Yeah, and I hear you, but I guess all I'm trying to say is we got to decide whether the risk of climate change is greater than the risk on the investment side, and how do we guarantee, all the diligence that's required to guarantee the next scale is great in the normal world, but the risk now is catastrophic. And so I think we need to start making faster decisions and supporting scale up so that we can get companies across the valley of death.
I think I don't disagree. I don't disagree. In fact, I completely agree with a caveat. And my caveat is that just because something could be a solution doesn't mean it will be a solution. So as an example, we could say, oh, it's so important, we must immediately start building a fleet of hydrogen carriers to bring hydrogen from Namibia and Canada to Germany. And it's not going to work. And when you see people saying, oh, well, you're such a defeatist, that I find, because we need to scale, but we do need to scale stuff that actually could get there. So I'm always, I laugh at solar roads and I laugh at wave power. I don't laugh at it. I don't want to be disrespectful, but it's not going to be part of the solution. Direct air capture, frankly, I think right now we're in a bubble of excitement about it. And I think if it can't get the costs of carbon down to well below $200 a ton, and I'm not convinced that it can. And similarly, if hydrogen can only scale, then I worried that we put too many eggs in those baskets, and that's a big concern because we don't have the time to waste pouring money into things that aren't going to be part of the eventual matrix.
I agree with what you're saying in that you don't want to throw money at things that are nonsensical. So let's talk about hydrogen and moving it across the world as a compressed gas. And if I stop to think about this, the problem we have is we cannot get ourselves mentally out of the paradigm that everything has to be concentrated and in a large centralized production. If solar has taught us anything, if what I'm doing has taught us anything, is that distributed approaches are the future. You saw the EDF study on hydrogen and fugitive hydrogen and so on. Don't make it at a central location. Don't distribute it as a compressed gas. Do it locally. Make it where you need it. And actually, quite frankly, there's so much waste energy at an electrolyzer. I can use that waste energy to run my distillation column. So I guess we need to step off the paradigm that bigger is better, that centralized is better, and get ourselves into a mode where we say the future carbon economy is distributed. It uses waste resources, which by definition are distributed, and that by scaling, scaling up, we will get what we need in terms of economics. And I think this is the problem we have. We got to mentally decouple ourselves from our old economy to create a new economy, rather than say, well, we're going to build the same thing, but we're going to use different feedstocks, or we're going to use hydrogen. No, we're not. No, we're not. And actually, quite frankly, liquefied natural gas, to me, I laugh at that. You laugh at certain things. I laugh at liquefied natural gas. Petroleum is the densest liquid known to man. That's why you can take it to a central location. Natural gas, you know how much energy we waste in liquefying natural gas, but we still do it because we're married to the idea that we have to do everything in a central location. We got to make something in a way that we can move it, and we liquefy natural gas, wasting tons of energy. But if energy is cheap and if natural gas is cheap, it makes sense somewhere on an economic basis. It is not logical from a thermodynamic basis. It is not logical from a future view. But we never look at these things, do we?
So I'm listening to this and thinking, these are such substantial paradigm shifts. And I map it back to the conversations that I've had many, many times with lots of people about how much money will this require? And they always want to figure like, well, is it 300 billion a year? Is it 750 billion? Is it $1 trillion? Or is it 3 or 4 trillion? And in fact, what we're talking about is potentially, the entirety of our economic system over the next 20, 30, 40 years is going to change. Production will be moving around. What is the right number? Who knows? We'll get back to finance. What I'd like to do is, could you walk now downstream from ethanol? Because you've said that there are, use cases in pharmaceuticals, there's use cases in fuels, but you've also got this business, LanzaJet, which is making sustainable airline fuels, which are not ethanol. They're not alcohols, are they?
No. Ethanol doesn't have the energy density to take a plane across the pond, right? You need a hydrocarbon. You need a drop-in hydrocarbon. And so, as you know, in my old job, my old gig, I developed the technology that was a drop-in replacement hydrocarbon fuel. that allowed us to show that you can actually fly on a biologically derived hydrocarbon. Yeah. And so when I came to LanzaTech, I realized, well, gee whiz, ethanol can be made from anything, and it's made by everybody. If we could take ethanol to jet fuel, that would be tremendous. And so we worked with Pacific Northwest National Lab and the Department of Energy to develop a technology to take ethanol to hydrocarbon. And we decided, we did flight demos, we demonstrated that this worked. And then we realized that we have a biological fermentation company and this thermocatalytic kind of refining process to take ethanol to jet. And keeping it in the same company made no sense, especially since it's very clear we have to make sustainable aviation fuel as quickly as possible. So it couldn't be part of a small company. So we spun it out as its own company, we capitalized it on its own, and we got it so that right now we're building a 10 million gallon a year plant. We have investment from Suncor, Mitsui, Shell, British Airways, and ANA and Microsoft are also helping with actually ANA with a prepaid offtake agreement and Microsoft with a loan. So really it's a whole family coming together to build a pre-commercial plant at 10 million gallons of production a year. And then what we'll do with each of the investors, we'll build commercial plants with them. So they committed to that next step. And so what that means is we're ready to go to the next step without stopping and getting financing, kind of like I told you at the beginning. So it's one of my concerns. So we structured it so that they could start doing the design of the plant while the 10 million gallon is being built, so they could actually start building their commercial plants as soon as the 10 million ticks the boxes. And because they're part of the family, because they're investors, they're seeing this technology develop and evolve. So they're kind of doing their due diligence in situ. And so what's happening is they're on a fast path to build commercial plants as soon as the first, that 10 million gallon is up and running.
And for the benefit of our audience, what is your sense? You said it, but it went by very, very quickly, that sustainable airline fuel is going to be very important. How important, if you look at aviation in 2050, could you give us a sort of what's your thumbnail? You know, how much of that will be, or how much current aviation will we simply not be doing? How much will be fueled by sustainable airline fuel versus other potential routes, be they hydrogen, be they electric, be whatever?
Yeah, no, that's a great question. So I'm going to take a 2030 view rather than a 2050 view. By 2030, the airlines have committed to almost 10% of the fuel being made in a sustainable fashion, so not fossil derived. Today, the world uses 100 billion gallons a year of aviation fuel, so we're going to get to 10 billion gallons a year by 2030. So now stop and think about that for 1 second. Today, the world makes 30 million. We got 8 years to add about 9.5 billion gallons. That is massive. That tells you how fast we have to build plants. And so that's what we're focused on. And we think of it as a hub and spoke with ethanol plants that are distributed, with the ethanol which can be moved, and getting that to a central location where you're building 1 billion or 2 gallons of jet fuel production capacity.
Right, because you said things are going distributed, but of course you've got this bow tie where lots of things can make ethanol, and then ethanol can make lots of things, and one of which is sustainable airline fuel. But once you've got to that ethanol, it's going to go into what's effectively just a really quite big refinery in the case of the alcohol to jet process, right?
That's right. And that's exactly how I think about it, hub and spoke. So what you can do in a distributed fashion, make the ethanol, and then the rest you do in a centralized fashion. We do the same thing with polyester, right? So we make ethanol in a distributed fashion, and we take the ethanol to a partner site where on a very large scale, they make monoethyl glycol, which is a monomer, which is then converted to polyester. And this is a path forward to utilizing waste in my mind. where you convert it to something that's transportable. You're not going to move agriculture residues 100 miles, but you are going to move ethanol hundreds and thousands of miles. And then all of a sudden, you leverage the best of distributed and centralized production methods.
And so how big of a farm or a farming area would you need to have one of your sort of that end of the bow tie, the upstream end, so you can then get it to the ethanol, and then it makes sense to ship it, truck it, whatever, to the on processing?
Yeah, I would say you want to be in the under tens of miles, right, to collect residue.
Right.
Residue, municipal solid waste, a city dump is good enough to make
a city of what, 250,000 people, that sort of size?
Yeah, under half a billion, yeah.
So half
a billion people, 500 million, yeah.
Wait, for one ethanol plant?
Yeah, if you have a city of
500,000, presumably.
Yeah.
Sorry,
Yeah.
I misheard. I thought you said 500 million, which is a lot of people.
That's a lot of people. I apologize. I meant 500,000.
Okay. All right. So this is good because we're getting a sense of this kind of architecture. There's everything has to change and the architecture has changed, but we start to see the size of it. Let's come back to this this question of financing. Now, you how much money there was that in that $55 million round back in 2012? How much have you raised in total for both those businesses, LanzaTech, LanzaJet? How much have you raised so far?
More than $500 million we've raised. So 17 years, $500 million, a little bit over that. And that actually doesn't include that the first commercials were actually financed by our partners. So there's also additional capital because we've licensed the technology. I don't think you can get a company that does a brand new process technology across the valley of death successfully with anything less than that. Yeah.
Well, congratulations to that. I mean, the French say chapeau, hat. They take the hat off. And I take my hat off to you because I just know that that is an awful lot of meetings with financiers, data rooms, closings, and lawyers' fees, etc. So I really respect you for that. That's a substantial amount of money. But of course, it's also in the scale of those billions of gallons that you've just been talking about, just for the airline fuel. But it's also only a start. And you have announced that you're doing a SPAC. So you've found a SPAC, a special purpose acquisition corporation, to acquire the business. So it'll be a public company that would acquire LanzaTech. So you would then be public, a transaction worth a few billions, and then you would be a public company, and that gives you access to different pools of capital. You were going to close that by the third quarter this year, which is in about 2 weeks' time. How's it going?
It's going well. So as you know, as part of the process, you do SEC filings, and they review your filings, give you feedback, and so you go back and forth with the SEC, providing answers to questions. The market, I would say we're on track to do it this year. That's our goal. You know, the SPAC market got a little bit ugly, and I think the IPO market got ugly too, and so things slowed down a little bit. But I would say we're on track, and we continue to move on.
Yeah, so the SEC became very kind of risk averse, and things that were just being waved through 2 years ago now seem to be getting very bogged down. Are you at all concerned?
No, I think the SEC is doing the right thing. I think, you know, at the end of the day, what the SEC is doing is protecting the investors who are going to be buying your shares. And I have no qualms with them being careful and making sure things are right. You know, it's sort of like building a plant, right? You don't actually want to build a process plant that's not safe. And you sure as heck don't want to go to the public markets and have somebody put their last dollars into something that maybe is a problem. So I have no qualms about the SEC doing what they're doing.
And can I ask, what's the fundamental motivation for the SPAC, for getting onto the public markets? Is it because there's usually sort of a blend of two things. One is a bunch of investors who want to sell, and so they need to access new investors coming in, or B, a way of raising a lot more money to be able to execute and push through your plans. What's the blend of A and B for you?
Yeah, so one is we are raising cash to go to the next stage. And the other is, frankly, it's time for us to go public. And the reason for that is we're probably one of the few companies that's developed a new process technology who's at our scale, right? And in some ways, I want the visibility that comes with new investors that will help us share that message, right? To be honest, I think there's a lack of hope that people can scale new technologies, that we can get away from everything being made from fossils. And I want other companies to learn that, to realize that, to know that it's possible to take an idea and turn it into something real.
A question for you on that. How many of your investors today have been with you for the full 17-year journey, or more or less?
Yeah, I would say two investors have been with us from the very, very beginning. But that was because there were only two investors in the A round, right? And so with the B round, people have stuck with us. There's only a couple of investors that had to close their funds and sell. Most of them have stuck with us. And I'm glad you said that because, you know, you mentioned Breakthrough Energy. They have a 20-year fund. When we were raising our capital, most of our investors had 10-year funds. 10 years is not enough for new process technology. That's why we have so many strategic investors on our cap table, because they don't have 10-year funds. And but now I think the world is changing so that 20 years or 30 years is an understanding that's what it's going to take. And no, I've been so fortunate. Our investors have stuck with us. It's been tremendous.
I think this is a key issue because what we saw, you and I saw, going back to the 2006, 7, 8, 9, 10 period, was venture investors who sort of said, you know, gosh, climate is important. Move aside, amateurs. We're the brilliant people who push technologies through from labs or from development through to commercialization. Takes about 5 years. You don't know what you're talking about if you think it's longer. And those people got very badly burned, didn't they?
They did. I think, and in fairness, I don't think it was clear because there weren't that many companies developing disruptive technologies before that, right? And how long does it actually take? How do you support it? How do you get there? And yeah, a lot of people got burned, and it's really a shame that that is not used just as a positive example of what it takes, right? Because the whole market's evolved based on those bad experiences. But I have to say, it was really hard for us as LanzaTech. We were right on the back end of that wave. And that's why we have so many strategic investors. It was really hard to get any financial investor to look at us after that bubble burst.
Absolutely, that caused that finished a lot of funds and a lot of careers. I think that bust, and then afterwards you saw people saying, "Oh, we're raising a fund and it's Clean Tech 2.0," and you look at them and you say, "Well, why do you call it that?" Because then, of course, you have to start explaining what Clean Tech 1.0, which just ended in disaster, was. And this is industrial innovation, and you're doing an absolutely brilliant job at it. But 17 years, maybe we could speed it up, as you say, by concatenating a few stages, but you're not going to get process technologies in chemical engineering through the process much faster than what, 10 years, 12 years? You know, how good can it get?
Yeah, well, I mean, I don't think you'll do much better. I think we did extremely well. I like to think if you've done it in under 20 years, you've done very well. And
so,
yeah.
Had you been able to keep your lab coat on, not had to go around raising finance, maybe you would have been able to go a little bit faster, but not that much.
Not that much faster. Yeah. I mean, you know, I think people forget that if you order a compressor of a certain size, it's going to take 14 to 15 months, and you cannot go faster than that, right? And a lot of people try to shortcut it by saying, well, I'll just use used equipment. Used equipment or old equipment to develop a new technology means you're adapting your technology to the equipment rather than getting the right equipment to prove that your technology works. I just really, there aren't real shortcuts, and that's what really scares me, because we have to be more creative about how we go faster.
So here we are, perhaps on the cusp of, I don't know, I don't want to say next generation biofuels or biotech 2.0, 3.0, whatever it is, but it does feel to me like some of those lessons are now fading into the rearview mirror, and we're certainly not going to achieve net zero without without the bio sector pulling its weight. I don't know what percentage it does of the solutions, but it's got to be a big piece. We're not just going to do it with wind and solar, that's for sure.
Well, I mean, at the end of the day, and you need carbon for chemicals, right? You need carbon for your clothes, your everything, right?
You need carbon to fly to New York, and certainly to fly to Hong Kong, or
exactly. Yeah. And so we have to say where your carbon comes from, where your comes from will actually determine our climate future, and that's the question. I think synthetic biology is the future, to be honest. Thermochem contributes and continues to contribute, but I think biology, with the selectivity and the ability to process chaotic, inhomogeneous waste feedstocks, is going to have a really, really important role to play. I would tell you, we focused all of our conversation on ethanol, and then taking ethanol and using it to make jet fuel, to make polyester. But I also want you to remember that the other thing we can do and have developed the ability to do is genetically modify our organism. And that way we can make acetone and isopropanol, other raw material building blocks that are essential to today's carbon economy. And so I really believe synthetic biology is going to have to play an important role in that, and also in food. You know, making food from air is critical, and we're going to have to change.
Jennifer, you've been such an extraordinary pioneer now for so long, and I can tell that we're going to have to, have you back to talk about the synthetic biology piece of what you're doing, what you've started to do, which I suspect would take us another episode, another 45 minutes to talk through. And I have no doubt that you have the energy, and you've had the learnings and the experience from the story so far to make that hugely successful. But I want to thank you for the time that you spent with us here today.
And thank you. I look forward to sparring with you some more. Take good care. Thanks, Michael.
And keep doing what you do. Well done. Thank you so much.
Bye.
So that was Dr. Jennifer Holmgren, CEO of LanzaTech. Next week's episode of Cleaning Up will be an audio version of my blog for Bloomberg NEF on the war in Ukraine, the Inflation Reduction Act in the US, and why 2022 is such a pivotal year for climate action and the shift to net zero. Please join me at this time next week for an audio blog version of Cleaning Up. Cleaning Up is brought to you by Capricorn Investment Group, the Liebreich Foundation, and the Gilardini Foundation.